Okay, standard 1. It says that students will design and conduct investigations that lead to the use of logic and evidence in the formulation of scientific explanations and models. So I think these standards are really wordy, and they put a lot of words in there and that they don't really need to get the point across. But they even add in all these A, B, C, and it goes all the way through H for this one. It tells you what you should know in order to prove that you meet standard 1. So for A, it's formulate a testable hypothesis supported by prior knowledge to guide an investigation. So some things that you should know to meet this standard or this section is what the hypothesis and what's the observation. What's the difference? What are they? What's the hypothesis? Educated guess, right? Because you take some observations, based on what you know already, you make a hypothesis of what is causing that, or if you change something, what would happen. Observations are just what you see, right? You can have, the next one we have qualitative and quantitative observations. So we'll talk about that in this next one. So design and conduct logical and sequential scientific investigations with repeated trials and apply findings to new investigation. For this one, what's the difference between a control and experimental group? Right, control is the same. Experimental, you change something. You're testing one of the variables and you change that variable for the experimental group. Like plant growth, you would have one with like just normal amounts of water, but then the next one you might vary the amount of water or vary the amount of sunlight or add something to the water. Those would be the experimental groups. Qualitative and quantitative. What's the close? So qualitative is just observations you can see or feel. You aren't taking any measurements. Quantitative has measurements along with it. Qualitative would be like the flame test. Remember the flame test way back last semester where we burn stuff and you look and they record the color? That's qualitative data. Quantitative, if we would have actually measured the wavelength of that and gotten a measurement of wavelength, that would have been the quantitative data. Anytime you take the mass or the volume, that's all quantitative data. Quantities, quantitative. Identify and manage variables and constraints. So the two different variables are the independent and dependent variable. What's the difference? What? No, they both change. Independent variable is something that you change. You would change it. And then the dependent variable would change based on the independent variable. So it depends on the independent variable. So like if you have a toy car and you are, let's say you change the force, you're pushing with a different amount of force, and you want to look at the acceleration of the car. If you're changing the force that you're pushing the car with, and then you would measure the acceleration of the car, and that would change based on the force that you give it. So the independent would be the force, and the dependent would be the acceleration. Okay, D, select and use lab equipment and technology appropriately and accurately. So what do we use to measure mass? A what? Yeah, what's it called? A scale or a balance, yep. And we have the triple beam balance that you could use. That's the one that you actually move the weights along the beam. We have electronic scales and balances, and then there's spring balances, spring scales. Do you know what a spring scale is? Yep, you're gonna. You see them in the grocery store when you measure produce, but this one right here, it measured newtons on this side, and you pull down, and it would tell you how many newtons of force that is. And spring scales are all based on springs have a spring constant. It's basically the stiffness of the spring, and so it takes into account which spring. It depends on the spring that you use to give you your reading. That's a spring scale. Volume. What do you measure for? Or what do you use to measure volume? If I tell you to measure out 10 milliliters of something, what would you use? Graduated cylinder. Good. This is the first class to give the correct answer.
Temperature is a thermometer.
Most people, the other classes said beaker for a volume. Beakers are not accurate. If you were to measure 10 milliliters in a graduated cylinder and then put it in a beaker, you would not probably see 10 milliliters. It's not very accurate at all. We use it for mixing. It's just a larger, it's not nearly as deep for the same volume. Another thing that you can use for volume is called a volumetric flask. You know what that looks like? Yep, I got one right here. So these are volumetric flasks. And they only measure one volume, though. So if you fill this container up to the glass etching right here on the neck, and the bottom and the meniscus is right at this line, then that would be exactly 1,000 milliliters or 1 liter. I can't measure 500 milliliters with this. I'd have to have there's different sizes. You'd have to have a 500 milliliter volumetric flask. This is a 25. This one's a 25,000. Those are the two extremes I have. Another flask that we have is called an Erlenmeyer flask. This also has measurements, graduations, but like a beaker, it's not very accurate. So don't use this to measure volume. This one we use a lot for titrations because you can swirl everything in and it doesn't, you have a thinner neck, a longer neck, so you don't have to worry about stuff spilling out as much. If you get too crazy, you would. Okay, so temperature, what did you say we measure that with? Thermometer, yep. Thermometer. Hopefully everyone knows that one. Microscope really doesn't measure anything, but it's a piece of lab equipment that you use to see the tiny specimens, right? Everyone's familiar? Have you used a microscope, right, in biology? No, Colton? You laughed like you didn't. Oh. But there's really no measurement that you take with it. And then what is stopwatch? Was that measure time? Yep. And then we'll talk about units here. Okay, you have to be able to use tools and technology to make detailed qualitative and quantitative observations. Parallax. You guys remember from the beginning of the year we talked about parallax. It is error because of a point of view. Example in lab that we do, if you have a liquid in a graduated cylinder, you need to look at it eye level, because if you are not at eye level, if you are standing above it, the measurement that you would take would be different than at eye level, right? An example from just every day, you might see this, is the speedometer in your car. If you're sitting in the driver's versus the passenger seat, do you see the same speed? No, unless it's digital. But on a normal speedometer, no, you do not see the same speed. So that's an example of parallax. And then units, let's look at the units that you use, the SI units. If you think of the MKS system. So SI units are all based on these. So length is the M part. The SI unit for length would be what? Meter. Yep. Mass is the K part, kilogram. And then S is the time part, would be seconds. Now, we don't always use the SI units, but we use metric units because remember the metric system has other prefixes that you can use. We will, most of the time for like mass, we use grams instead of kilograms. And that's just a unit of measurement that we use, but the SI units are based on the meter, kilogram, and second. And every other unit, like a newton or a joule, those are all SI units, but they're all based on the meter, kilogram, and second. One that's not in here is temperature. What is the SI unit? Kelvin. But for the metric system, you can use Celsius also. And we will use Celsius almost always until we get to the gas laws. When we talk about gases, we have to be in Kelvin. And so we'll convert Celsius to Kelvin. We don't have anything that measures Kelvin temperature, but it's an easy conversion. Well, 0 Kelvin is absolute zero, so that's equal to negative 273 Celsius. So normal room temperature is 27 Celsius, around there. And so Kelvin temperature, that would be 300 Kelvin. It sounds hot. Yeah. Derived units. Derived units would be like a gram per milliliter or meters cubed, because it's derived from two different units. Milliliter is also a metric unit that we can use for volume, but what would be the SI unit for volume? Based on our SI units here, volume is length times width times height, really. So it would be a meter times a meter times a meter is what? Meters cubed. So that's the SI unit, but you might see centimeters cubed or milliliters or liters. Those are all metric units. Okay, represent and review collected data in systematic, accurate, and objective manner. Graphs and tables. We do a lot of that in our labs. One thing for graphs, questions for this could be like giving you graphs and tables that you have to interpret, asking you a question about it, kind of like on the ACT. You probably won't have to draw. It's all multiple choice, so you won't have to draw a graph. But the independent variable is usually on the y-axis, and then the dependent variable is usually on the x-axis. So if you think about when we were pushing our cart, the independent variable was force. So we would have the force versus, and then we looked at the acceleration. So acceleration was our dependent variable. This is just an example. And then you would look at what the relationship was. Now for force and acceleration, it's a direct relationship. It's linear. And so when you have a linear relationship, you can find the slope. And you would have the rise over the run. And for this case, since we're looking at force and acceleration, do you guys remember the equation that relates force and acceleration? F equals mass times acceleration. So if we have force and acceleration, they're directly related. As force goes up, acceleration goes down. There's a constant here, and that's what the slope is. The slope is equal to that constant, and so our slope would be equal to the mass. So that's an experiment you could do. You could vary the amount of force, find the acceleration, graph it, find the slope. That would calculate your mass of the cart or car, and then you can measure the mass and see if your measurements were correct. See if they agree with the actual measurement. Questions so far? Analyze and interpret data, synthesize ideas, formulate and evaluate models, and clarify concepts and explanations. Theories and laws, what's the difference? It's been tested, and usually it has evidence that would support it, but there might be some evidence that does not support it. It just doesn't have a large enough body of evidence for it to be considered a law. And then in law, usually has some sort of mathematical relationship also that and it explains a set of theories. So several theories could be under the law. Use results to verify or refute a hypothesis. So once you have a hypothesis and you would test it, collect the data, analyze the data, once you look at those results, if it agrees with your hypothesis, you would go on to sharing the information. If it did not agree with the hypothesis, what do you do? You'd remake it, change your hypothesis, and then test it again. Yep. So that's what I is: propose or evaluate possible revisions or alternate explanations, and then you retest it. And then once you have a set of data that agrees with your hypothesis, you could share that. Share your procedures, results, conclusions, and defend findings to a scientific community. And that community could be peers. It could be, for us, our class. Has anyone done a science fair? Share. You're sharing your results with the public. Scientists that are doing, like at universities that are doing experimentation and publishing, they share it with the journal, and then there's a group of other scientists that would review that, and it's called a peer review journal because other peers in the scientific community review it, and if they think it looks legit and it looks like they followed the correct scientific method, then it would get published. Evaluating scientific investigations and offer revisions and new ideas is appropriate. We kind of talked about that, revising your hypothesis and retesting it. And then making sure you use appropriate mathematics in all aspects of scientific inquiry. Now, I know you can't have a note card or anything with equations, but I'm pretty sure there's a little button that you'll be able to push at the top that has some formulas for you. Periodic table, I'm not sure if you can have a paper copy or if it's electronic also. But that's why we're going to take the tests on the computer with the same software you'll take with the science or the actual standard test. So that way you get used to what you have available to you also. The program, once you open the test, it locks you out of everything else. So you can't change programs, so you can't go look up stuff online when you are in that test. So you guys, grab your clicker. Well, we're done reviewing. Now we have some practice questions. So these came from Check for Learning, and again, they're just samples of what could be on the actual test.
What is this thing, Miss Taylor?
Each time it clicks, it's a meter. If they bought them, yeah. Did? Where? Oh, yeah. They bought them. All of Adams Central has. Okay, well, I got push start. Hold on. Okay, now you can answer. It should say. So what piece of lab equipment would you use to accurately measure volume?
It says waiting for question.
I push start. It should be coming.
Question. Well, that was cute.
Okay, the answer is C. So round bottom flask actually doesn't have any graduations on it. It's just a big round with a flat bottom, and it's used for heating stuff up. Student wants to design an experiment. Read through the experiment. To determine the effect of temperature on the rate of chemical reactions. What's the dependent variable? You forget your glasses again. Contacts. Remember, dependent variable depends on the independent variable which you change. So which one is he changing? And then what depends on that? Yeah, what if your name's Mary?
All right, so you're going to break something. Sit down.
Okay.
Yeah, that's what it was.
Answer is, yes, it is B.
Because the temperature is like what will affect it.
Yes, so he's changing the temperature. The effect of temperature, so he's changing the temperature and effect of the temperature on the rate of chemical reactions. So he's measuring the chemical reaction rate, how fast the chemical reaction occurs. Metric units for volume. To be metric, they all need to be metric for volume. Ooh, we're very spread out. The answer is B. Okay, A, meter, liter, gram. Is gram a volume measurement?
Yeah.
No, it's a mass.
My book it is.
Okay. Milliliter, cubic centimeter, liter. Yes, these are all the metric units. They are all units for volume, but they're English units. They are not metric units. And then D is all weights, all masses. not volume.
It's not as bad.
They're all metric, but they're not.
Oh, was it? What'd you put?
What must be true of a hypothesis to be accepted?
Well, I feel like all of those are correct. You ever even use this saying, Miss Clear?
We use it for physics in one lab.
What way you do that around?
We go out by the highway and we measure off and measure based on the distance and time we find the velocity of cars. Oh.
I put A. I put it must be correct.
No, it's B. It must be testable. You must be able to test it.
Correct too.
No, because it might be wrong. Your observations might show that it's wrong.
Who else put A? Me too.
For a hypothesis to be when you make a hypothesis, you have to make a hypothesis that is testable, that is observable and measurable.
I thought you meant to be accepted into like the sciences.
Oh, as accepted as right? No.
That's why I put correct.
I see where you get that.
I don't wanna.
So a student pushes a cart with a mass of 2 kilograms at 3 different levels of force. The student measures the time it took the cart to travel, 3 meters for each force. What's the dependent variable? You change the independent.
How many more questions do we have?
Ooh, we're about 50-50 right now.
Who put A?
Answer is A. Yes, the time.
Good job, guys.
The mass of the car. Do we change the mass of the car at all?
No.
No, it stays at 2 kilograms, so that's not a variable. Force of the push, we change that, but the student is changing that, so it's not dependent on anything. The student is changing it. So the force of the push is the independent variable. And then distance traveled, it's always the 3 meters. So he's not changing the 3 meters. He's measuring the time. The time is what's changing.
Is that the last question?
Yes.